Hello and welcome back. In this video we're going to show you how to use some of those laws of exponents on algebraic expressions. First example is 5x cubed times 2x squared. First thing we're going to do is multiply the 5 and the 2 together, and that's going to give us 10. Now when we go to multiply the x's together, we're going to leave one base. And we're going to take the exponent of 3 and add it to the exponent of 2, because anytime you multiply like bases, the rule is to add the exponents. So the final solution here is just going to be 10x to the 5th power. This example is pretty much the same. We're going to take a negative 2 and times it by the 6 first, and that's going to give us a negative 12. When we go to multiply the r's together, we have an r, single base r, and a 5 plus 8 exponent, and we're going to simplify that to be 12r to the 13th power. Negative 12r to the 13th power, and that's the final solution. In this example, we have an exponent that's raised to another exponent. Keep in mind that what this really means is to show the negative x to the 5th times the negative x to the 5th 2 times. But that's a lot of work. So the rule or the shortcut here is to simply multiply the exponents. So we're going to write it as x to the 5 times 2, but remember there's a coefficient of negative 1, and it's going to be raised to the 2nd power, and negative 1 to the 2nd power is a positive 1, and I don't really need to show that 1, but I'm going to leave it there for now. So bring it over, I'm going to leave it as 1x, and then the 5 times 2 gives me a power of 10. So instead of adding the exponents, I'm going to multiply them. Power raised to a power will be a multiplication. For this example, we still have two things that are being multiplied together. The only difference is we have multiple factors inside of each one. We're still going to multiply the coefficients here first, which will be a negative 6 times 2, which is going to be a negative 12. And then when we go to do the multiplication of the m's, we're going to bring down a single m, but I have a 4 and I got a 1 on my m, and since I'm doing multiplication of like bases, I'm just going to add the exponents. So that's going to be m to the 4 plus 1. And I'm going to do the same thing with the n's. Remember, there's also a 1 on this one, so that's going to be times n to the 3 plus 1. And then if you do the full simplification here, you'll get negative 12 times m to the 5th n to the 4th power. So this whole thing reduces down to this expression. Same thing on this example here. I have 3 big factors and multiple factors inside of that. Since I don't have any exponents on the outside of any of these factors, I don't have to worry about distributing that exponent. So the first thing I'm going to do is multiply my coefficients. So I have a negative 1 here, a positive 1 here, and a negative 1 here. So negative 1 times negative 1 is going to be a positive 1. Now since I don't really need the 1 on there, I'm going to go ahead and erase it. Then I'm going to go in order. Next is going to be the p. So the p to the 3rd power times p to the 1st power times p to the 2nd power is going to give me p to the 3 plus 1 plus 2. Now I will move over to my q's. q to the 3rd times q to the 1st is going to give me q to the 3 plus 1. And the last step is simply to simplify. P to the 3 plus 1 plus 2 is p to the 6th power. Q to the 3 plus 1 is q to the 4th. So this entire expression simplifies to p to the 6th times q to the 4th. Okay, on this example, we have a combination of a multiplication in the middle, but we also have exponents on the outside, the 3 here and the 2 here. Now if you follow the order of operations, you must do the exponents or the powers first before you do the multiplication here in between. Now when we raise a power to a power, we have to multiply. And don't forget your coefficients here have exponents of 1. So I have a 3 times the 1 gives me a 2 to the 3rd power. Bring down the r, and a 3 times a 2 gives us a power of 6. I'm going to leave those in parentheses because I haven't finished multiplying yet. Bring down my parentheses. I got a 2 times the 1 here, which is going to give me 3 to the 2nd power. And there's also a 1 on this r, so 2 times the 1 here is going to give me r to the 2nd power. So a power to a power is a multiplication of the exponents. Well, now we're just doing regular like base multiplication, so we're going to add the exponents. First of all, this base and this base are not the same, so I cannot just multiply them together right off the bat. So what I need to do is simplify it a little bit further. I need to call this 2 to the third power. I need to call this 8, and then r to the 6 is there. I'm just simplifying that. And the 3 to the second is just going to be 9, and r to the second. If they had like bases, we could just go ahead and multiply them together and then figure out the answer at the end. But since they didn't, I can't multiply them together. Now I can go ahead and multiply my 8 times the 9, and I get 72. And the r to the 6 times the r to the second is going to give me r to the 6 plus 2 power, which is really going to be r to the 8th power. So this whole expression at the top, when simplified, comes out to 72 r to the 8th power. Here's another example where we have a multiplication between two factors, but we also have exponents outside those factors. And we have to deal with those exponents first. When we raise an exponent to another exponent, we're going to multiply. So our first one is going to be g to the third times 3. So 3 times 3 is going to give us g to the 9th power. H to the first times the 3 is going to give us h to the 3 power. Now there is a negative here, so that's really a negative 1. In most cases, that's not really a big deal, but since there's a negative on it, a negative 1 raised to the third power is still going to be a negative 1. If that was an even exponent, then that would make that a positive 1 instead. You must be aware of that. Bring down your g, and we still have a power of 2 times 3, which is going to give you a power of 6. And h to the second times the 3 is going to give you h to the 6th. Now this is a negative 1 in the back and a positive 1 in the front, and together they're going to leave you with a negative 1. Now if you don't want to put the 1 on there, that's fine. You can just call it negative. Now we go to the like bases. G to the 9th times g to the 6th, and anytime we multiply like bases, we are going to add the exponents. So the 9 plus the 6 is going to give us a g to the 15th power. And then we're going to go to the h's, and I got a power 3 and a power 6. That's going to give me h to the 9th power. So the entire expression up here, when simplified, comes out to negative 1, or just negative g to the 15th, h to the 9th.